Okay, I think we're back. Oh my god, I'm such a noob. What's up, Creationary 3D? How's it going? I'm just gonna wait for a few more people to get back into the chat here, and then we can keep going. Yeah, XC10, we are back. We are so back. I'm such a noob, guys. I can't believe it. so silly. I've been streaming on a unlisted stream for like the last 10 minutes, and so nobody even knew I was back on. For anyone who was here before, I apologize. And I'll keep saying that until we have a few more people in the chat here. I'm such a noob at streaming. I'm not a noob at engineering. What's up, Green TNT? Doing well. All right, we are so back. It's crazy. We were so gone. I don't know what happened before, but my internet just like absolutely cut out. And like, I know we're not supposed to be streaming on Wi-Fi, but it wasn't even the Wi-Fi that was a problem. It was literally my internet completely cut out. But if this happens again, we are just gonna end up plugging in directly with a cable, the old school way. Which printer do I recommend for beginners? I recommend, honestly, there's literally any printer you get now from like one of 4 brands, like Bamboo Lab, Prusa, Creality, what else? Snapmaker has a pretty good machine. Basically anything you can get your hands on, everything's pretty good right now. 3D printers have come a very long way. So I'd recommend whatever you can get that's like, you know, affordable to you. Accessible is the most important. Once you get it, you can figure anything out. Okay, so for anyone who was on the stream before, you know what we're doing. We're redesigning the Dye Rotor mechanism that we designed before, and this is where we're at. So right before the stream cut out, I just threw this gear onto this piece, and that's kind of where we left off here. So this thing goes this way. This thing will turn this back on. Oh, this must be. There we go. So we're trying to get it to do this. Basically, is what we're trying to do. What's up, Bean Guy? And ultimately, oh, that's actually pretty good. This thing is going to be scooping ping pong balls into the center, and they're going to drop out the bottom. And then this is going to be rotating the other way. Bean Guy, this is the second live stream of the day today because my first one cut out because of my internet. But this is we're working off of kind of what we started on last Friday. Caron Naxoli, what is up? Welcome to the stream. SolidWorks does cost money, but SolidWorks for makers is only $50 a year. So yeah, terrible internet. I know, what the heck, but it should be fine now, right? I think everything's back to good. Everything's excellent again. We're higher than the recommended kbps, so we're back in business. Hopefully that doesn't happen again. If it does, we're gonna have to have a talk-in to my internet provider. Oh, bonjour. Comment ça va? That's about the extent of my French right there, so apologies, can't do better. Okay, so what we need to do is basically get this design ready for printing. So the basics are there. We have a motor driving this guy. We have to get the motor also driving this guy, and so that's kind of what we're doing next. But before we do that, I think what I'm going to do is kind of build out the mount that's going to hold this motor and also allow me to attach this to something. So let's do that next. It's kind of a quick but sort of boring thing. But we're going to make a plane. Engineezy. It's kind of fun to say when you start saying it. Start getting the Engineezy. And we're just gonna make the plane down here. We're gonna put a sketch on this plane. And this is gonna have this big hole for the balls to go through. Yeah, that's good. And then we're gonna have a little circle like this. And then we're gonna have it kind of extend out like this, and then have this, and like this. I don't know if I want to talk about it. That's a sore subject. No, I've spent like thousands of dollars at this point on filament, but this is my job, you know. So it doesn't count. It's different. It's different than if I was doing this as a hobby. You know, my job is my job is to try not to worry too much about how much I'm spending on filament. Let's put a hole for the motor here, and that's gonna be the distance that we said, which is 64, but I'm actually gonna give it like a 0.1 millimeter, just a little bit of clearance there. And then we gotta make the holes to mount the motor, and those are 31 apart, and they are 3.5 big. And we're gonna put a line here, and that's also gonna be 31. Before we get too confusing here, let's just trim this and this, boom. I'm a mechanical engineer. So like traditionally mechanical engineers can do a lot of things in the engineering world. One of them is like machine design, basically. Beard printer, welcome. I'm glad you made it. We're talking about what mechanical engineers can do. Nowadays, mechanical engineers can design robots and a lot of like mechatronic systems, manufacturing systems, which is pretty sick. I love manufacturing systems. Mechanical engineers can design HVAC systems. And this is kind of unnecessary, sticking out like this. So we're gonna do this instead. I don't know, what else is mechanical engineering? I don't know. There's a lot of things. But for me, I'm a silly robot, a silly marble machine maker, basically. This is really live, swear to God. I chose mechanical engineering because there's so much you can do with it. It's just, there's like, the possibilities are huge. And that was the reason why I chose engineering in general. And it's gotten me in so many places. Amit, to answer that question is a little bit of a complicated question that it would be kind of hard to answer exactly. But I would say, this may be a controversial opinion, but talk to AI. Ask it that exact question and then talk through the answers. But I don't know. Don't hate me for saying that. I just think that that's what a time to be alive, you know, that we can do that. You can have a very specific person helping you with your very specific thing. Okay, let's answer these questions. So how much time does it take to print? I don't know, it really depends on what we're making, but we can look at this when it's done and we can figure that out. Why did I decide on SolidWorks? I decided on SolidWorks because I started using it in university, got very comfortable with it, and now I just really like using it still. I just know it really well. And what is my favorite printer? I don't really have a favorite printer right now. I use the Bamboo Lab printers a lot. I guess the P2S is a really good printer, but Bamboo Lab as a company is a little bit, I don't know, a little sketchy. So yeah. So, okay. Do I have any suggestions for mechanical design? All I can say is just watch what I'm doing here, and that's my best suggestion. I've read the sequel. This is an interesting question. I was wondering how engineers, experienced designers, or engineers are always putting a bunch of interesting details like the little tabs for screws. I'm not exactly sure what you're asking. Maybe try rewording that. And I'm not exactly sure what you're asking, but okay, let's get this done. I didn't solve this final thing here, but it's because I want to come back. I'm not really sure what we're gonna do with that, but we're just gonna make this base so you guys can see what I'm doing here. Basically, I'm just making a flange that I can attach the motor to. So right now, let me just take this. I'm from Canada, Toronto. Let's get rid of this. Let's just make this not transparent for a second. Now I'm gonna mate this with this. And we're gonna mate this with this. And I'm gonna turn this like this. Yeah, like that. And that looks pretty good. So this application that I'm using is called SolidWorks, and it is a paid application, and I'm using the professional version, which is quite expensive. There is a maker version of it, which is also very affordable, and it's basically this exact thing, which is like crazy, and I think it's $50 a month or something like that. I am sponsored by SolidWorks, so just want to be clear about that, but I don't say only use SolidWorks. I say like you should use SolidWorks or Fusion or Onshape or whatever you can, FreeCAD, Blender, whatever you have available to you, because you'll find a way to make the things that you want doing it that way. With any of these softwares, they all can get you to the end goal, and I'm a firm believer in that. Okay, so what I've done is this. The plan is to basically take this, attach the motor to it, and then screw it into this. So we got to add that. So that's going to be attached to this. And we need to leave like a space here because we have these big gears that are going to be like this and this. These are both equal. They're both 64 millimeters. Okay, so we have lots of space for these flanges. And maybe I'll put one here like this. And maybe like this. Let's just think about this for a second. When the next video is coming out, I don't know. I've kind of been taking a little bit of a break right now from like the long form videos to just go after some like fun, you know, quicker projects. Try to take some of the stress out. I don't really know what I'm doing here. Hold on a sec. Let's make that 15. Let's get rid of this. But yeah, you know, try to have some fun. Follow some of these side quests. Where do we want to put this guy? What am I trying to do here? Let's just take a look. Let's just have a think through this for a second. So if we're trying to put this thing together, this is a very important thing to think about when you're designing things. The question is, what's the order of operations? So I think what I'm gonna do first is I'm gonna push the bearing to this, sandwich this rotor into place, which means that this gear is gonna be here. And then if I push this up from the bottom, am I gonna be able to screw it in from here? Yes, I am. The reason I'm thinking about it this way, so basically I'm gonna be screwing down through this guy into this guy. And so I'm gonna have the screws sunk into the base. Oh, actually no, I forgot that I made this thick enough that I can screw up into this. I actually have no idea why it's called the Dye Rotor. I was thinking maybe it's like someone's name who invented it. Some guy like Mr. Dye. Yeah, no idea. Okay, we have a plan, let's execute. So this guy's just gotta be here. And I'm gonna make a random pitch circle for that. And we're gonna do this and put it down here. And we're gonna make this 92. Oh, okay. Well, you just gotta watch how we're doing it, because we're doing it. This is actually all part of the process here. And like right now, I'm actually making screw holes. Or maybe it's for mixing dye, maybe. And this guy is gonna go up to this surface, but I wanna make sure that it's only connected to this. So now I have that, I'm gonna make my screw holes. Like this. This is gonna be for a number 4 thread forming screw, which is, hold on a sec, this guy right here. Focus. Anyways, you can't see it, but this is a thread forming screw. So I always make my holes 2.75 and then I try to make them bigger after, but If I do this down through there, and I actually need to show this guy again. So that's going to go through all that way. And on this side, we're going to go up to offset from this surface because I don't want it to go all the way through. We're going to go offset to only like 0.5 millimeters. Okay, and now, because we're printing this, this is going to be on the flat on the bed here. And I need the screw to come up through this and into there. So what I'm going to do is make a hole like this. This is going to be for the head of the screw. And that'll just make 7. And then when I cut that out, I'm going to go down, but I'm going to offset it like, I don't know, 4 mil. Boom. So now you can see we can put the screw in this way through here and then through there. But because I'm printing this way up, I'm actually just going to put a chamfer on this. Definitely does. My efficiency is way lower during streams because I always get sidetracked. But it's fun. We're having fun, and I like answering you guys and keeping you guys in the loop. So, yeah. I mean, I'd love to hear from you guys, though. If you want to see me just, like, absolutely crushing at my normal speed, I'd have to not answer some of your questions. So, but I think it's more fun that we're, like, here hanging out, right? Let's make a circular pattern of this and this. The problem with the circular pattern here is that the hole I made goes through this guy, and that's a problem, I think. Let's just see. I don't really know. Sometimes I get confused. Hanging out's fun. I agree. Who needs to be efficient? Features and faces. We want this. Okay. We're good still? Still good? Still good? Still good. No. It's so annoying when it does this. It says use the geometry pattern. And I say all bodies. And then it says don't use the geometry pattern. The reason is because this is cutting through 2 different features. But if I just get rid of this, we can pattern it. Take all of this circular pattern around this hole. Cannot find end face for feature. Come on. What is your problem? Oh, I know what the problem is still. This guy, I got to get rid of this. Okay. So I basically just use the same screw threads for every single project. Main reason is it makes decision making very easy, and that's an important thing when you're making a lot of decisions. Oh my God, what is your problem? So frustrating. Okay, we're doing this a different way. Oh, that was no, maybe. Okay, let's try this again. This is the patterning features in SolidWorks sometimes are kind of frustrating, but if I make that a separate body, screw off. This guy, edit feature. What's up, Brock? I think this might give us the same problem, which is kind of annoying. But it might work. I'm trying to make them literally the most simple part right now, and I'm struggling. Okay, now we're back. What I'm trying to do is literally just pattern this feature, and I think what I'm gonna have to do is do it in multiple steps. Circular pattern. Sorry guys, sorry we're getting bogged down on this crap. Bodies, this. That's what I want. I just want 5 of those. I have lots of experience. This right here is project 200, and that's only since I started Engineezy. So before that, I had many, many projects under the belt. So I have 200 plus another, I don't know how many, but a lot. Okay, that's what we're trying to do. Now I need to pattern this hole. And then I need to circular pattern. Let's see if this works. This might actually work this time. Boom. And then I just need this hole. Oh my God, guys, this is so frustrating. It's so frustrating. This is what we're gonna do. We're gonna get rid of this cut. We're only gonna cut into this. If there's anyone from SolidWorks here watching this right now, please fix this problem. Okay, now we can do this. Now I can just make the holes again. I appreciate you saying that. Thank you so much. I plan to continue doing them at least for the month of June, and we'll see how it goes from there. Okay, let's cut through this piece only right here. Oh no, not that was the wrong one. That guy's going the other way. This one is cutting through this piece only. Boom. And then now I can circular pattern that. Honestly, sometimes there's, okay, that's good now. Now we can combine that with all of these guys. Boom. Yeah, I guess I'm understanding that right now. It's so annoying. And then this guy, we're gonna cut up, offset from the surface here, 0.5, and then we can circular pattern that. But honestly, I think that I'm using too many patterns. I don't know what best practice is here, guys. Many ways to do it. Okay, perfect. That's done. So all I was trying to do is just create a mounting system for this bottom bracket right here. And we may even adjust that later, but for now, everything's good. And so now you can see we have a place to mount the motor. And now we gotta make holes for the motor. Let's just do that quickly. So we have these holes, but I also want to counter bore some holes for the motor screws. And that we're gonna make 7 as well. Select those all, Alt E for equal. That's just my own little shortcut, but it's good to have shortcuts when you guys are doing CAD. Allows you to be very efficient. My age, I'm 35, and I started as a mechanical engineer. Okay, let's just see what we got here now. So if we hide this, you can see we're gonna screw through this into the motor. So that's gonna hold the motor in place. And I'm just gonna do a little mate to hold the motor there, boom. And this is gonna screw up and into, where's this guy? Into this, show. So this is gonna screw up into this. So what my plan is, I'm gonna put this in, screw it into place. So now we gotta set that up. Let's fix that part now. So basically, the reason I'm doing this as multiple parts, see there's right now 3 parts, even though that's actually, yeah, let's just combine them. So is because I need to print this guy on this surface up because of this. If I printed it this way, this would all be supported. I mean, it's probably fine, but I do remember Pokemon. I loved Pokemon when I was a kid. Like, loved it. Like, I wish Pokemon existed in real life. Maybe one day it will. That'd be so sick. Just like little robot Pokemons. You can go to like a, I don't know, go to like a little Pokemon theme park where you can actually catch Pokemon in the wild. Wouldn't that be fun? But yeah, I do remember it. I think there's people here who would not remember it that way. Okay, we're gonna make some holes in this guy, and I'm just gonna use some reference lines to line it up in the center. Select midpoint, that, make it coincident. Make sure that this and this are coincident. Make this why don't you turn it, there we go. Okay, purple, there we go, beautiful. BattleBots, ooh. You know, it's crazy, like, at one point in my, like, BattleBots was another one of my favorites. I'm just gonna make this. We're gonna make 4 holes. That should be more than enough. I don't think we're gonna be dealing with any exceedingly large forces here. 2.75. The 2.75 is the perfect hole size to thread these number 4 screws into. And then we just gotta give this some dimension so it turns purple. 55 sounds good there. And on this one, I want it to be right in the middle between these two. So I'll just do this, this, oops. Boom, and make that and that equal. Okay, sick. Cut that out. I'm gonna go up 10. And my idea is to go through the whole thing. And then just like, hopefully that will just sandwich everything together. And I don't have long enough screws, but I can use my number, when I make hole sizes for number 4 screws, it fits M3 screws as well. Really just like a good little hack. So we're gonna go this way through all, make sure we're cutting this part and this part, boom. And honestly, I don't really need to counterbore that, so I'm not going to. So let's just see from there to there. No. From here to here is 16, and I have 25 millimeter M3 screws. Should I make them M4? I have some longer ones. Should be fine. I think it's gonna be fine. So now we can see we have this part. So the way that this is gonna work, if I make this transparent, I'm gonna put this here, I'm gonna put this here, and then this on the bottom, and I'm gonna put some screws going all the way up, and that should squeeze this whole guy down onto this bearing right here. That's in this big part. And then I'm gonna put this on and then screw it in from the bottom up. And that looks like we have enough. It should be strong enough. I'm not too worried about it. So that solves that problem. The next thing that we have to figure out is how to get this thing to spin. And what I'm thinking I'm gonna do is I'm gonna have a bearing. It's basically, honestly, it looks like a paint mixer, and it could probably work as a paint mixer, but it's a ping pong ball dispenser. So okay, so we gotta figure out how we're mounting this guy. And if I put a bearing on the top of this guy, there's 2 ways I could do this, I guess. One way is I could have like a thing that comes out like this. You know what? There's actually a few ways I could do this. I could probably just have a piece coming off of the top of this because the balls will just fall through it. No, you can't do that because this is gonna have paddles coming down. Just so we remember, these paddles are gonna come down and those are gonna agitate the balls and make sure that they're getting down and into this thing. Okay, so we need a way to mount this without it getting in the way of anything else. Yeah, I think we're gonna have to go off the top of this guy. So this is gonna be a crazy part. Off the top of this guy, we're gonna need somewhere to mount the bearing. And I think I'm gonna use for this, let's see. Like realistically, we could probably use a bearing that's this size. Just feels wrong. I would probably say that I'm an introvert, but I don't mind being in like crowds and stuff, but it could be prone to jamming, but I don't think it's gonna be because ping pong balls are so light that they'll just move out of the way. But we're gonna find out. We're gonna find out by printing it and making it actually work. Yeah, Paul Wall, we went back to the original idea because I wanted to be able to adjust the speeds. That was the main reason. So yeah, we're back to the original idea. I'm just trying to figure out a bearing to use for this. I'm gonna go with a bigger bearing. Let me just find one. Let me see what I got here. I can take you guys with me actually. You can look at my bearing. Let's see. There we go. Just make sure this is working. Come on. There we go. So I have this bearing drawer right here. And how about this one? That looks like a good size for this. Again, this is probably overkill, but it just feels right to me. It feels like it's gonna be stable. Come on. Okay, come on with me. So this is I'll show you where this is gonna go. Back to SolidWorks. So this bearing right here is, let's see if I can remember. It is 37 OD, 25 ID, and then 7 thick. 37 OD. So that's what's gonna go right here. Yeah, when I use big bearing versus, honestly, all of these bearings are like, all of these bearings are more than overkill for what I'm building. I just like this big bearing because it's gonna like, I feel like it's just gonna be more stable with the 3D print. It'll start to make sense in a second. But right now we just need to build this place where we're gonna pop the bearing. So this is 37, perfect. 37 OD, it's perfect there. And then we're gonna put this here. Yeah, exactly. It doesn't matter. It really doesn't matter. This just feels right. And that's like so non-technical. So I apologize for that. I'll just put it here. And that's 7. That's gonna hold the bearing, blind. And we're not gonna merge that. Just wanna make sure. Yeah, I mean, the way I normally work is I'll try to get something like ready for the evening. Before I leave, I'll run all my prints, and then when I come back in the morning is when I'll test something. And then basically that allows me, if I'm moving fast, that allows me to iterate in the morning, run some test prints like during the day, and then in the evening test it. And if I need to change something, I can make the change, run that print overnight. But yeah. One thing I want to make sure is that this is going to allow marbles through. Looks like it will. It's 45. Sorry, marbles, ping pong. You know what I'm talking about. And I think I'm just going to reuse this sketch at the top because it's already done. So we're going to go off this surface, down, 10, and up through all. And we're going to go all bodies, boom. There we go. So the bearing is going to go in here, and then that's going to screw onto the top of this. And let's see what that looks like in the assembly. And then this guy is going to have... sometimes I use equations, but rarely. I mean, I've like rarely encountered like literally anything that I've ever done for Engineezy where like I've been held back by equations in math. So like in university, everything is very theoretical. In the real world, honestly, a lot of times it's like you're often not doing like breakthrough math. But maybe I'm wrong. Maybe someone here does do breakthrough math. But like when I was working for the golf company, for example, we were using like a spreadsheet that already had all the math built in. How long can it take to make the parts? Everything that I'm making here is gonna be 3D printed, so it's gonna be pretty quick. Okay, so just so we're gonna test my design thinking here. So basically what's gonna happen is we're going to put a bearing in this. We're gonna screw this on. We're gonna slide this up from the bottom of the bearing into this guy on the top. So we need to actually have a flange here. So I messed something up there. It's a quick thing we gotta change. Here, we're gonna do this. Set a little flange distance, boom. And then on this guy, sketch, we're gonna use this edge. It's gonna go, oh, problem, no, never mind, it's fine. This is just gonna be a like little like spacer. So that's a spacer because we're printing this way, from this way up. So yeah. Yeah. It is definitely getting like the design logic is definitely way more important. Why couldn't the face of the gear act as the flange? Because we're printing up. So a lot of things that I do are actually like purely so I can manufacture it. But so now we can put this here, boom. By manufacture, I mean 3D print. Big word. Okay, so that's there, and now we're like actually like really getting close. So we obviously just got to increase the height of this. So we need another 10.5 millimeters on that. I'll go 11. 60. I'll go 2. I don't like 61, but 62 is nice. Perfect. And now the last thing we need is to connect the drivetrain here to this up here, and then we'll figure out the spacing and make sure everything's good to go. And another thing is we're gonna have like a way to get through to that. So what we need is basically just a shaft going up to here. Okay, so let's figure out. This is 1-to-1, so whatever speed the motor's moving at is going to be the speed that this rotor moves at, and hopefully there's enough torque. I'm not sure, but we'll find out. If there isn't, we can replace these gears, right? So that's kind of the plan. And this gear, a little bit of that makes things a little bit trickier because we'll figure that out. We're going to figure that out. If we want to replace the gear sizing, we'll make the thing up here. Okay, so this is what we need. This is what we need. This is a 180 tooth gear. This is going to move pretty slow relative to this. So if this is 100, this is 200 tooth gear. If we had a 64 tooth gear coming off of this to this, let's just adjust the gear mate so we can kind of get a better idea for how it's going to move. So this guy is, let's say 64, and this guy's 180. What if it was, let's see what that's like. Okay, that's actually fine. All right, so let's just pick some arbitrary gear size because I don't really know how much speed this needs to be. XE10, that is a many girlfriends. Many girlfriends. Not true. Not many girlfriends. I was an engineering student and I was busy. Engineering's hard. Engineering school is hard. Okay, we're just gonna do this. Oh, Period Printer, thank you so much, man. I really appreciate it. So unnecessary. So unnecessary. I'm here because I'm like excited and happy to be here. And it's fun to be sharing my work. But I really do appreciate it. I really do. And I appreciate you hanging out. Let's get some gears in here. So I think we're gonna use, let's see what we got. If we go into our CAD file, maybe we're just gonna use a 25 tooth gear. I don't know, guys. I'm making it up. Oh, you know what actually is the important thing? Is I have to figure out what's gonna fit here and here. Yeah, that's actually okay. Now we have something to work off of. Sometimes the freedom is tricky. So we have a 64 millimeters. You know, I'm just gonna draw a sketch. This is a in assembly sketch, which is what this is saying, but this is just for reference, so it doesn't really matter. So that's 64, and then we're gonna come out to here. So basically we need a gear that is going to fit onto this guy, this pitch circle, and is also going to fit onto this guy's pitch circle. So that is the problem that we have at hand here. That might be a little bit tricky, but we should be able to figure this out. And for the sake of this, I'm just going to do this. This pitch circle is 64, and this pitch circle is... So I could technically solve this entire thing with like math, but I can also solve it doing it this way, which is just using sketches and CAD. And this is the way that it just suits me better. So that's why I'm going this way. So, okay, this and this are tangent, boom. And there we go. So if we made this pitch circle 25, what is this one? 37.18. I mean, none of this is ideal here, but if this was 37.18, it'd be fine. And if you're confused about what I'm doing, it's going to start to make sense, I promise, in one... You know what? Let me just give you a quick... No. Let's stay focused. We're staying focused. We're staying focused. Okay, we got to figure out what the right pitch circle is going to be for this. So if this is 36, this is going to be 23.82. That's not going to work. Man, this is a confusing challenge, actually, which I didn't really think about. Alternatively, I can change the size of this gear. Let's just see what happens if I make this gear the same pitch circle as this. If I make them tangent like that, what's the size of this? 51.8. Let's hear it. Let's hear the idea. Because then this would have to be... $76.4. None of it lines up. I really wasn't planning for that at all. Classic. This is always the way it goes. I love a good dumb idea. But something that I'm missing is this. These two should be able to... Let's see. Oh, let's get rid of this. If these two are equal, 60. Okay, we're making a quick change here, everyone. We're gonna use 60-tooth gears here, and it's gonna work. I mean, Doritos are carbs, right? And carbs give your brain energy, and you need brain energy in order to make engineering happen, right? Bevel gears. Don't be crazy. That's crazy. No, we're just gonna use gears. I don't know what a T-Series tank auto-loading system is. Did you just watch Blue Paw Print's video, and that's why you're saying that? It's like fresh in mind. That video's on my list of videos to watch right now, but I haven't gotten around to it yet. Okay, now here comes the fun. If this can't really be smaller than 60, but if it's 64 and this is 58, then that should solve the problem. Let's just make sure that's true. If this guy is 64, because that's what it is, and then this guy is 58. Oops. Get rid of this. We have solved our problem. Okay. Let's make that quick change here. So we're just basically swapping this for a 58 tooth gear. Let me see if I have one close by. Sometimes it's easier to just go into my CAD file and go 58. Come on. Tell me I have one. No. Oh, that's annoying. 64. So I gotta change both gears. Unless I just make one. Which I could just make one. I know I have one that I've already made. Decisions. Laziness is a real thing, you know? Okay, so why not use a chain or a rubber band to spin the other part, which is something I've thought about as well. And that is because you have to tension the chain of the rubber band somehow. Or just get it exactly right, which is always hard to do. And tensioning is always a little bit of a tricky thing, and gears are easy. I'm just being lazy. We can make this math work for us really well. We just need a 58 tooth gear, and I'm going to show you guys a little trick here. Let me just make sure this trick works. Oops. KHK gears. So this is a little trick. This company, KHK Gears, is a really great place to go and get 3D models as well. And let's just see if they have a 58 tooth gear here, because that's going to make life so easy. Module 1, number of teeth, 56, no. But they do have a 72 tooth gear. Do I have a 72 tooth gear in my gear library? No, we're just going to download that. All right, we're doing a little bit of a change here. No. Change my mind. We're going with 60 tooth gears. We're going to make it work. I know how to make this work. We're just going to do that. It's easy. It's convenient, sort of. It's inconvenient, but convenient at the same time. Let's just grab a 60 tooth gear, 60T. I know I have one already made. M1, 60 tooth for, let's do this copy. There you are. Okay. Now we're gonna get rid of most of this. All we need is this. Okay, get rid of all of this. Okay, we're back. It does have a feature to generate gears. It's just a little bit cumbersome to use. And I mean, there's probably other ways to do this. I just find this easier, although right now I'm making it look very hard. But this is gonna, it's fine. I'm just being lazy, guys. I'm just being lazy. This is what we're gonna do. We are gonna take this and we are going to, let's just put the part in first, actually. Make this a little bit bigger, like 4. The problem with the 60 tooth gear is this. If I insert it like this, yes. Put this and this together. Put this and this together. This is the problem. You can see that the flange sticks out past the gears. Actually, I kind of like it now, looking at it like this. Yeah, so there's weird workflows in every single software, but okay, now we're gonna get rid of this, and now it's gonna break everything. But we're gonna fix it all. So this guy, edit sketch plane, this guy right here, edit features, make sure that we're cutting into this, boom. We're still good. Combine, okay. That's kind of nice. Look at that. It's the exact right size. Boom. Okay, let's see what that looks like in the actual CAD. Not so bad. This was like the thing I was thinking would be the biggest problem, but I think it's gonna be fine. You could, and you can do it with a, you could probably do it with a planetary gear, which is the way that it worked in that reference video. But this way is going to work completely fine. So I'm okay with it. And we're going to save this as a copy and open spur with coupler. Boom. Insert part, browse, shaft coupler. Shaft coupler. I'm always driving the view with my mouse. So I'm just using my mouse wheel. I don't know. There we go. Add. Boom. Boom. We're back in business, everyone. Now we go here. We're going to get rid of this. Get rid of all of this stuff. And we're going to insert component. That spur with coupler. Boom. Boom. And then this guy and this guy are going to be mated. Okay. So now I got to adjust the spacing right here. Just simple. We're going to make it 60 now. 0.1 for a little bit of clearance on the gears. There we go. Everything is back to where we want it to be. And now we basically just got to figure out what we want our gear ratio to be from this to this to this. Let's hear your question. But everything, see how these line up now? Like mostly, like good enough. They should line up perfectly, but I don't know what's going on here. 60 plus 60. Yeah, it'll work now. My scroll wheel, I don't know if it's inverted or not, honestly. Yes, you should be concerned about that. I actually have a very similar problem on my editing computer. I'm running out of space, and I'm concerned about it. But I have a lot of junk on that computer that I could probably get rid of. Okay. We're gonna make now this shaft that goes up from here to up here, and the way that I want to design it is a gear all the way up, and then I'm gonna have like a little flange to hold it up here, and then it's gonna connect to this guy. So let's make that, and I think we're gonna stick to that. What did we have? I think we had a 25 tooth gear. Let's see. Did I bring it in? No. CAD. Screw it. Let's go with the 30 tooth. No, let's go with the 25 tooth. 25T. Copy. Back to this guy. Control V. Paste. Change the name to PPPA. Oh, I already did that. It's already there. Okay. Never mind. Let's open that. And then, oh, that's why it's that guy. Interesting. I remember what that's for. Okay. PPPA underscore that with shaft. Okay, boom. So now we got that. We're gonna do this. And make this, we're gonna use, for this guy, this bearing right here, and the inside of that bearing is 15, so we're gonna make this shaft 15, and we're just gonna give it an arbitrary height for now of, I can't remember what the height of it, 50, and I'll show you where this is gonna go. Insert components. This guy is gonna go here. And we want to go this way. Okay. And maybe I need a bigger gear. Look at that, I do. It's so annoying. Okay, let's get a 30-tooth gear up in here. Maybe we'll go 36. Better to be safe than sorry. This is like sometimes, you know, the engineering process is a lot of doing annoying things, you know, over and over again until you get it right. But when you think about like, what I should have really done there was made a placeholder sketch just to see what kind of spacing we had, but I didn't. And so now we got to do this whole thing again. But one thing about doing something a second time in CAD is it's almost always easier because you've already made all the decisions. You know, so it's a quick process at that point. So I'm just gonna make this 50. This hole here, I'm actually gonna make smaller. I'm actually gonna move it down here, and I'm gonna adjust it to this face, and I'm gonna go like this. That's what I'm here for. If you're gaining something from this about your own process, like that's all I could really hope for, is that you're gaining something valuable. And I'm going to use M4 screws for this because I have these. Which bearings are they? I don't have any here in my kit, but these like bearings that I just always use, and they really get the job done nicely. And I'll show you what I mean by that. So basically, okay. Let's just fix this guy first. So this distance right here is the distance from this to this, which is a 60-tooth gear. This is how I normally do it here. 60 plus a 36-tooth gear. Divide that by 2. 48, and I'm gonna give it a little bit of clearance, plus 0.1. We might need a little bit more clearance, but there we go. And we'll make that look a little bit less ugly too. We can close this. We don't need this anymore. And we'll get rid of that. We don't need that anymore. Insert this guy. That's what we need. This and this now mated. Boom. This and this mated. Boom. And we're gonna have to get some clearance off of the bottom of this. What? There's a weird mate here, which we're gonna fix now, because if we forget to fix that later, it's gonna cause us a problem. It's this one. There we go. So this flange has to mate with this face of the bearing. Oh, this is confusing. Let's do that again. We need this bearing here has to mate with this flange here. Boom. Okay, nice. And I'm gonna make that transparent again. I'll do a sandwich check after to make sure everything's right. Something's wrong. It's probably this isn't big enough. Oh, no. The problem is actually that this flange is going the wrong. What's the problem? That and that should be 10 millimeters apart, but it is 10 millimeters apart. So where is that coming from? Section view for the rescue here. Oh no, we're actually good. Everything's good. The gears are inside of the drum on the lid. Yes. And no, you know what I'm seeing right now? This gear is actually not straight. So now I know why that's... Guys, it's all coming together. Let's fix that now. And put that and that plane together. And put this plane and this plane together. Now it should be centered. There we go. Oh, and we are so back in business. That is so much better, guys. Whew. Jeez. Okay. Okay, we're actually very close to done now, which is amazing. So everything's starting to look like it's aligning. We'll fix some things after. We might have to make a hole for this, but let's just finish this first. So what we need next is a little flange for this guy. And that's gonna be at some arbitrary height off of the top of this. And I'll put it 6'7" for now, because 6'7", right? Sorry. Sorry. It's gotten in my head. Okay, and then this is gonna be a bearing here, and this bearing is going to be this guy right here. And the outer dimensions of this bearing are 24. So let's do that, because the bearing is gonna press fit into there. And hopefully tomorrow we're gonna be able to put this thing together. And the reason I'm making this its own piece and not like a part of this outer body, so we can change it later if we want to. Okay, and this are going to be concentric, very nice. And we'll do that. Yeah, it's true. And this bearing is, I believe, 5 millimeters thick. Yep. And this only needs to be the thickness of the bearing. But maybe we'll make it a little thicker to accommodate some screws. And that's going to be its own piece, which means I'm also going to do this. Put a little flange so we know where the bearing needs to live. The reason I always do these flanges offset from surface is because the bearing diameter is fixed, or the bearing thickness is fixed. And so if I change the thickness of this, and I'll show you when I do that, I just want to make sure I merge to this guy only. If I was like, you know what, this needs to be like whatever, 12 millimeters thick, it keeps the space for the bearing the same. So just like a really like good way to save yourself from future heartache. Okay, and now we need a way to screw this into place. And this is a little bit of a challenge. But what I think I'm gonna do, because I could screw this way, but this isn't thick enough to really have a counter bore. So I should probably make like this a little bit thicker here. Or I can screw down into this guy. Which I think is what I'm gonna do. So we're gonna screw down into some flanges coming out of this. The reason I'm doing that is I want this to be adjustable. So I don't have to reprint this if I decide that the gear ratio is too small. Yeah, screw down. All right, Thomas, we're on the same page. My man. All right, let's make those holes, and then we'll make the flanges for them. We'll do it all at the same time here. So I'm just gonna do like this, and like, I'm not gonna get too fancy here. All it really matters is we have enough space for the screw head, which is about 5.5. So I'll make my 6.5. That gives us enough space. It's gonna come to about there. So we're just gonna say that this here is, look at that, 420. We'll make it 5. This is for construction. This is the hole that goes in the center. What's our problem here? The thickness, we're gonna give this a width of 7.5. Sounds good to me. That's gonna be out of the way from everything, from the bearings going through. Nice. Paul, what do you use the equation tool for? This is 2.75. And we're gonna make a little center line here. Do some trimming. And we're gonna take all of this, like chain and this, and mirror. And we're gonna go blind, and we're gonna make them, I don't know, 5 sounds good. We're gonna merge only to this guy. And then because I'm printing this up, I'm just going to give this a chamfer like this. And we'll make it 9.5, looks good. And then we just need holes in this here. So sketch, circle, boom. And there are gonna be clearance holes on these, which I make 3.5. Make those 2 equal, oops, and cut. And we're just gonna select this body, boom. Okay, that is good and ready to go. So now we need to just figure out how tall. Let's just get the spacing of this stuff done right first. So I'm just gonna extend this face out. So I have some clearance. And that is, I went further than I need to. Like that. Okay, so that's clearance on there. And let's just turn off the transparency there. So there's clearance there. This looks like it should fit as long as, no, my shaft coupler doesn't fit, but I'll go through the top. We should have more than enough space for that. Where'd it go? Oh, I suppressed it. Unsuppress. So that's causing a little bit of a thing, but we should be fine with that. And then that's good there. So I'm just going to get rid of this. Move face. I think now everything's the same thickness. Okay, so from here to here, 69. Let's go. Yeah. By Dye Paintball. There you go. Thank you, my memeplex, answering a question that we've had. I don't know if that question came up. Sorry if I missed it, but I was like thinking, was Dye Paintball? Is Dye the name's guy who started that company, or is Dye related to the fact that paintball dyes things? Okay, now that we have that, we can move this. Move copy bodies. Ooh, one thing I should do if I'm planning to do that is not merge these yet. And not do that yet. Okay, move copy body. And we want to move copy this guy. So I want to go up over this guy, but only 1 millimeter. So let's see what that might be. And looks like it's 73, so we're gonna move it 74, boom. Now we can put that back in, and you'll see here, if I make a little sketch on that, and then do this, and make that 16. And then we're gonna go up to surface, and we wanna go up to, there's always a way to find the surface. And we're merging that to this. So now when we look at this, boom, look at that. Beautiful, beautiful. And I just happened to hit that in the exact right spot, which is like so nice. Okay, so now we need a hole here. So I'm gonna make a little bit of a hole on this guy. And I'm gonna make the hole bigger than we need it, just in case we end up using a bigger gear down the road. Trim. Yeah, it's fine like that. And we're gonna give this a dimension. 18 sounds pretty good to me. This should be vertical, and we can cut that down to this face, up to surface, this face. And we're only cutting this guy. Boom. Look at that, guys. We're so close. So we have a way for that to interact. There's clearance. That's perfect. That's perfect. So the only problem is this thing. Oh, no. We're good. Everything's good. But we need to countersink some holes into this guy so it doesn't interfere with the gear. Or counter bore, I guess. And we'll make them pretty tight to the screw head, 6.5. Make those equal. Cut. Golf Simulator update is I'm still waiting on a launch monitor to arrive. I may try to do, there's like an open source launch monitor, which I may use, but I kind of want to have something that's like dialed in and camera based, not radar based. So I'm waiting for that to come. I think it's like back ordered or pre-ordered or whatever. So that's not coming yet, but when it does come, I'm gonna do a little, I need to do something to the ground, the floor, the frame thing, so it can return the balls easily. And then I'm gonna build like a little like robot ball placing. There's a lot of stuff that I wanna do for that, but as I mentioned in the video, it's good enough that I can use it, and that means it's good enough that it can distract me from the things that I wanna do for it. Okay, look at this, guys. So this is ready to go. All of this is good. I'm very happy with it. We gotta adjust this to make it look better. I'm going to do this, I think. Edit sketch. Let's just see. I could do that. That works for me. Tangent. Boom. And oh yeah, this hole here needs to be 13. Oh, it is already. Nice. And then this flange. Maybe I'll make this flange. Let's see. Wintergarten's marble machine is just an insane piece of engineering. So he actually takes a lot of heat for like how long his projects take, but spending that much time on the projects is like, that's what allows you to do really incredible stuff. It's not amazing for YouTube videos, but it allows you to do really, really incredible stuff. Is there enough material on the outside of the bolts? If we're talking about here, this doesn't really matter because there's more than enough material from here to here, right? That's like 3 or 4 layer lines. My first question to Nikola Tesla. That is something I've never thought about in my life. I have no idea. I don't even know what Nikola Tesla did. Someone remind me. Oh, look at this. We have a problem, everyone. Good catch. That would have been annoying if I didn't catch that. It wouldn't be the end of the world, but right here, if you can see, this is in the way, but we can fix that. This darn pattern, man. I should have done this completely differently from the way that I did it. This pattern's fine. Like what I could do is, if I take this down, equal spacing, I just need these to be here and here. So like if I do like, I don't know, 300, would that fix our problem here? No, because it's not centered. Oh God. I'm so unhappy with how I did this. I should have done this. Sometimes, like, I was trying to save time, but like, I'm just gonna do this. That's the way to do it. What did I have for lunch? I had the saddest lunch today, guys. But I always kind of do. I just have like some like chicken, just like plain chicken from Costco, and then like a yogurt drink. It's so bad. It's so bad, but it's quick. I just pull it out of the fridge and we're good to go. What did we do here? So we went 60 and 3 this way, and we're just gonna mirror it. Oh, Paul Wall. That's probably another good way to do it. But maybe, yeah, screw it. We're gonna do it that way. I like that. Paul Wall always coming in with the. So what are we gonna need though? 7 maybe, maybe 6. Is that what you were saying? Use 6 and then remove the center one. Yeah, that makes the most sense. Thank you, sir. Do the same thing here, equal spacing 6, and remove this guy, and then change that here. And that's why the way that I've done this absolutely sucks, because I have to change 3 features. But we're here, and we're not changing it now. Okay, that's done. This is all good to go. Right now, I'm not hiring because I just like working by myself, but I will definitely let you know. Did you just finished university, right? If I'm remembering correctly, or college? Okay, this all looks good. The only problem we have now is this guy. And what we can do, there's like some easy ways to fix this, which I think I'm just gonna do this the easy way. Oh yeah, on Wednesday. Where do you go to school? Are you in Canada, by the way? Or are you, no, you would have finished already if you're in Canada. Okay, this guy, we're just gonna, right now we're just gonna move this guy down. Print some spacers, problem solved. That actually solves 2 problems because that allows me to get an Allen key in so I can tighten the set screws on this. And so we're good there. So there's one more thing we need here. And that is, why didn't I do my master's in engineering? I didn't do my master's in engineering because I kind of just wanted to get to it. In Norway. Oh. But yeah, I just wanted to get to the field. I was tired of school. Sometimes engineering school is a little bit, like it's just not the same as real life school. Okay, last thing we need to figure out is how we're going to like mount this basically and like hold it up. But this is what the aluminum extrusions are for. How are they? Boom. What motors would I suggest for a ball throwing machine? Depends on what how you're trying to throw the ball. How you plan to throw the ball is the first question I would ask. So I'm trying to decide if I want to put this on this guy. This guy, how I'm going to get into place is I'm going to screw up through a bearing here and into this guy. And then on this side, I'm going to screw, I got to finish that. We're going to get to it. I'm going to screw down through this guy, and that's going to clamp onto this gear right here. And that should hold it in place. It's not going to go anywhere. Okay, I think, where did my aluminum extrusion go? I think I'm going to actually I'm going to attach this extrusion into right here. So let's open this. And that means I'm actually going to make this a little thicker. Maybe we'll go to 8. just for strength. And then here, we can decide where we want our extrusion to go. And I'm just gonna make this reference. This is where the edge of the extrusion is gonna be. And then this is the other edge of the extrusion. Doesn't matter if it hangs off a bit. And that's 20. And I just wanna have enough clearance from this hole. That's where the balls are gonna fall through. And the balls are gonna be 40 millimeters. And that's kind of where they're gonna be falling. So actually we have a lot more space than it looks like because we can actually overlap this. So you know what though, I'm okay with this. I just wanted to not go off the edge of this, but obviously the closer it goes this way, the better, because it won't be like overhanging too much, but it's gonna be strong enough. The nice thing about working with ping pong balls, I said this in an earlier stream, but I'll say it again, is that ping pong balls are light. And that means that we don't have as much, like, we don't have to worry as much. And we're gonna make a little line there, and we're gonna come off the center of this guy to about here, and then the holes for the screws that often that I'm using for this are 5.5. So I use 5mm screws in my aluminum extrusions. If you guys are confused by all the different hardware that I use, I am too, so don't worry about it. We'll make that 42. Boom. Oops. Take this and cut through the bottom of this guy through all. Boom. And we're gonna make some counter bores on that. There is, by the way, a hole tool that potentially makes this easier, but honestly, I find that I'm quick enough that I don't worry about having to do the second step. And the hole tool, you still have to make the sketches and the dots and everything that I just don't bother with it. We're gonna make that blind 2.5. That should be enough for there. Okay. I don't use variables because I find that it breaks often. And maybe they've improved it, but I just find that it breaks, and so I've never used them. I also find the like having to use like setting up the like I'm just like faster at typing in the number, and I rarely have to change hole sizes because every hole size I use is pretty standard. So I kind of just do it. It might not be the best way to do it, but it's just the way that I do it. Okay, so now we can just put this where it's supposed to go and make sure that everything's good. So we're gonna put that face there, and then we can grab the sketch that we just made. Show, and that way we can use this reference for this guy. Boom. And then save everything, and let's just show all the parts and see how that looks. So that's gonna be like that. One thing that I don't have in here, I guess it doesn't really matter. Yeah, I don't, like for whatever reason, I've never had success with variables. And so I just don't use them. Okay, that's fine. Basically, the only thing I really need left is to attach like the speed reader, which is literally just 2 LEDs and a tube, but I'm gonna make the tube specific for this so it doesn't get in the way, and I can attach it to this guy. Let's just actually make sure one other thing. These are gonna be spinning, and there's clearance there, I believe. Yeah, there's clearance there. Let's just make sure that the screw heads are not gonna be, I think it's gonna be fine. Let's just see. What's that screw head? That's gonna be an M3 screw. And the screw heads on the M3 screws are 5.5. Yeah, we should be fine. Shouldn't be a problem. So the only thing, so right now in this current form, like it's really not a problem, but man, I just don't love that. That's why I wanted to use bigger gears. You know what we're going to do? We're going to bring the holes in on that guy. Let's just open that up. And this is the sketch that we're going to adjust. Edit sketch. And what is constraining this? I forget. It's probably this right here. And we can just give this a dimension. I'll call it 50 for now. Boom. So now that's where our screw head is going to be, which is way better. But the other thing is our tube. All right, this is like the last thing. So we need a tube that's coming out of the bottom of this thing to be able to direct the balls wherever we want. You know what, actually, I want to move this way. There's actually a problem here with this guy being here, is I have to screw this into this before I can put this into here. So I would have to screw this. I have to screw this extrusion piece in first. It's fine. There's enough. There's enough screws. There's enough. I think 4 is enough to hold this together. Okay, it's fine how it is. It's fine how it is. Let's just put our last piece in, which is our tube coming out of this. And our tube coming out of this is literally just going to be a tube that I'm going to screw into the bottom of this guy. And I want it to kind of have like an opening that will fit this. And it's not going to interfere. Okay, let's make the tube. And it's going to be like this, maybe. Maybe it will start on this face. I do think that AI is going to one day take CAD jobs, or at least make CAD jobs easier. And on one hand, it's a little bit scary. But on the other hand, I'm trying not to be too afraid of AI taking jobs because ultimately it's a bit like knowing what you want, right? Like if I was working with a junior engineer, what's going on here? Oh, we're done with that. If I was working with a junior engineer, I would basically just be telling them what I need and then they'd be doing it. And that's kind of how AI works right now with like coding. If you want to like make an app or something, you just tell it what you need and then it does it for you. So I'm not being clear because I'm trying to do 2 things at the same time right now. But yeah, hopefully you guys get it. Someone else fill in the gaps for me here. Looks like Posked's got it. Okay. Let's make a little feature with this here. And what I actually want is this 1.6 for the exit tube. Boom. And edit sketch. It's like, we're so close here. But then there's all these like last minute things that you remember you have to do that you forgot to do. But nice thing is we're actually done this before the stream's over today. I think like we're gonna be on the printers tonight. I forgot that it doesn't like when I do this, but okay, we're just gonna do this. Boom, and then boom, and boom. And we're gonna do this, which is start constraint, end constraint, normal to profile. Beautiful. And we're gonna shell this guy out. Shell. Make it 1.6. I'm kind of vibing my stream right now. Like I don't have a plan exactly yet for how often I'm going to be streaming or what. But when I have like a kind of like fixed task like this that I'm trying to get done, and I feel like I can get it done on stream, that's kind of how my plan is going to work moving forward. Okay, so one problem I have with this here, we're just going to look at our section view here. So the screw heads are going to be a problem, but maybe I'll countersink the screw heads into this guy, and then they won't be a problem. And then the balls are going to fall through the center, through this guy. I'm going to have my LEDs to read the balls here. Guys, we are almost there. How much thinking do I do before I start to design? It depends on the project. Sometimes I'll like try to think it through. Like sometimes I'll have the whole thing thought through all the way. Other times I find it's easier to think it through as you're building it in CAD. So I'll kind of do like a drawing, quick drawing, like, you know, the drawings. I'll show you what my drawings look like often before I get to something. So here's an example right here. Let me show you. So this right here is an example of like a drawing that I'll do before I start designing, where I kind of have the basic idea of what I'm trying to achieve. And then like, you know, then I'll go into CAD and I'll make the big parts and then like kind of vibe from there. But yeah. XE10, to answer your question, why don't I master in engineering? I mentioned this before, but I was ready to get into the field and start working. And mastering in engineering means like picking a specific thing and researching that. And like, there was nothing like that really interested me. So that's why I just jumped right into to working in the field. Okay, this guy, we're gonna just do a quick little countersink or counter bore on this. And it doesn't matter if there's a thin wall here, because I don't think it's gonna matter. Boom, boom, Control A, make them all equal, give them a dimension, 6.5. It's gonna be a little bit close to the edges in certain spots, but it doesn't matter because that's printing this way. And what matters more are these holes. Okay, we're good. And then now we got to figure out how we're gonna attach this guy to this. And I'm thinking I want it to attach from the bottom up, because that's just gonna be the easiest way to do it. And I'm gonna print it this way up. So let's do it like this. We're gonna make a couple intersection curve. One thing is, whatever, it's fine. I'm gonna do like this. This is a little bit, I don't know, maybe it's a little bit sloppy, but it's fine. It's fine. Make a hole there, 2.75, even though that's a clearance hole. I always say, I've said it again, I'll say it another time. I'm making that the threading hole diameter because I just don't want to accidentally mess it up later. That looks good to me. Make that horizontal to that. Give that an arbitrary dimension that just looks right. 69, that looks right. And then we actually have to offset this. Kind of need the inside edge on that more than anything, but no, that's too thick. We're gonna offset this entity right here, just this guy. Hopefully that's enough. What is your problem? That's weird. Okay, we're just gonna do this. Like this. For figuring out the spring for your pen, I would say just get some springs from Amazon or wherever and just test it. Hard to beat that. What do we attach to? Oh, yeah, that works for me. Okay. Now let's extrude that. Exactly, trial and error. What's our problem here? Oh, no, what's our problem? What is it? There's an extra line or something somewhere. It's not this. No, it's not that. Not that. Is this not connected? There we go. Maybe. I don't like when I'm not getting clean contours, but like, what am I missing? Oops. It's fine. Oh, nice. Computer printer. Did you guys see the giant pen that I made? That was a very fun project. It's a very fun thing. Let's see if this works. So if that's like that. Sometimes I do. Sometimes I use cardboard. If I'm doing anything, often it's with cardboard. But I don't have enough Lego to like be able to make a proper prototype. So, oh, weird. No, that's not good. Edit sketch, oops. Edit sketch. I'm getting to that point in my day here where I'm like, doing CAD like this, where you like just like grind the CAD out. That's where our problem is coming from right there. It's actually right there. You start getting tired of making decisions. And so, you know, stuff like that, but we're good. Okay, everything's better. Okay, and that's screwing up like that. So, and this is getting a little bit gross, but we're gonna do this, but we need a screw to go up and through that into this hole. And so I don't really need a flat surface, just kind of be ugly. I use mainly bamboo lab printers. Okay, if I wanted to do this first and screw down through this. Oh man, I feel like that's probably the right way to do it. Okay, sorry guys, we're gonna undo that. Okay, let's just think about this through first. So I'm trying to think about how I'm gonna assemble this so I don't get to the point where I'm trying to assemble it and realize that I missed something huge. But let's just see. So here's the plan. Basically, we have this part. In this part, we're going to attach the motor and we're going to attach the motor and then we're going to put this thing on. So we're going to have just this and this part, and then separately we're going to have built this guy with this guy. Yeah. The reason why I made the cone this way is because I want to have some clearance between the top of the cone and this thing, which is going to be rotating. And so I made it a cone so the balls will fall into this and then down and through and hopefully just go right down, just have enough clearance. Yeah. Basically, it's just so we're not rubbing against this piece. There's only 1 millimeter of clearance, so. I will be putting this, I'm gonna make a short about this when it's done. But yeah, so, okay, basically the cone can end up being, oh, yeah, no, the cone can be part of this basically. So let's just get rid of this. Sorry for all that silliness. It can be part of this bracket, but I'm gonna be printing from this way up. So I have to screw it in separately. And so that's why I'm doing it this way. But I'm gonna screw down. So I'm gonna print the cone like this up, which means that those flanges can be on this and I can make little holes for the flanges to go into. We're almost there. No, I'm going back to how we had it. Uh-oh. Are we dropping frames again? Are we still we're still here? No, we're still here. Weird. Connection successful. You're thinking about like interference fitting this onto this. Yeah, I guess it could. I'm just not big on the interference fit. We should be back in business here. Okay, good, good. There's a million ways to do it. I could even screw it into place, but I don't feel like making threads. Oh my God. The Wi-Fi, guys. The Wi-Fi. No, I'm not gonna just let it rest. That's too leaving things up to chance. I want it screwed into place. Okay, going back to the original plan, we're gonna just use this, but instead of screwing it this way, I'm gonna go from the top and screw it this way. Okay. Oh no, we don't use Thread Wizard. Yeah, seriously. Okay, at least we haven't dropped the stream again, because that was frustrating. We're doing this way because I'm so over this design at the moment, and like this is just a side quest. This is just a side quest, guys. 3.5, beautiful. Oops, always. And we're gonna cut that up through all like this. Oh no. No way. I don't know if you guys are still with me. You know what the problem might be? I think you guys are still here, but I'm like losing memory. I don't have enough memory right now. Oh my God, you guys are still here, right? Tell me you're still here. Tell me we're still streaming. We are. Oh my God, my computer is like I'm like using like the maximum of my RAM. Okay. My tab, like I've never actually had that before with the tab closed. You know, I need to 3D print more RAM. I think that's the problem. I don't know if I just had too many tabs open or what. Okay, we're still good. Nothing's changed. We're just cutting holes here, and then I'm gonna make a little counterbore on those. Boom, boom. That and that equal. And we're gonna make it 7, and we're gonna cut it 2.5. And we're gonna make that blind, and that part's done. Now, the only other thing that we need on this guy is somewhere to attach the LEDs. And so what I'm gonna do is on this plane here, I'm just gonna do this because we're printing up. So I'm gonna make it look like this. And I'm kind of getting lazy, guys. I'm not gonna lie. Normally at this point I would take a break, but because we're so close to finishing and I wanna finish on stream, I'm just gonna show you the lazy way to do things. And that is this and this. I really don't like using selected contours, but yeah, you know what, it's fun. It's actually not, now we're not in the lazy way anymore. Now I'm doing it the long way. This is one thing, like doing this in SolidWorks is always annoying. I don't know why. I don't know why. I wish I had a better reason for you. And this is the thickness of the LEDs, which are, I know. Apologies for the stream keeps dropping. I'm wondering if it's dropping because I'm out of memory on my computer. I gotta close this. And I gotta close Bamboo Studio. No. Hopefully that will keep the memory. I don't know if that's why the stream's dropping or whatever. I do take creatine and it does help, but when you've gone now for how long we've been streaming for, like I can't even remember. making decisions like this is just hard. It's hard on the system. What are we missing? Now we just need this height. And we need this and this, boom. And then what I'm gonna do is I'm gonna offset the start of this, however many, 50, that's way too far. 25, and then we're gonna go this way up to next. And I'm not gonna merge it because it's not gonna be happy with me. That's a weird SolidWorks thing. If I was trying to mirror that part, it would not mirror it, which is frustrating. But there we go, boom, bodies to mirror, boom. And I'm gonna combine them, boom, boom, boom. And we're gonna cut through the whole thing now. Through all, boom. Yes, it does have a built-in thread feature. I rarely use it because when I'm 3D printing threads specifically, I make my variant like a special profile for that. And yeah. Brock, we're making a really fast ping pong dispenser and we're kind of just in the final stages of the grind here. So now if we go back to the assembly, I just want to make sure, so that's going to go up through there. That's going to fit, no problem. I'm going to screw in through there. Motor's going to be there. The whole thing's going to go up. I need to just make sure that the bearing that I'm putting in here has a flange. AI is not quite there for CAD. Maybe I'm wrong. Maybe it's changed in like recent days, but at least in the last 2 months, I haven't found a system that makes AI fast, but okay, just making a flange for this bearing, and the bearings that I'm gonna use here is 5mm thick. And no, actually, I think I wanna go the other way. Rarely, if ever, do I use the thread feature. Generally because I'm always just threading directly into like smooth holes. So I've never had to. And 0.5 up to offset from this surface, 5mm. Whew, this is a grind, guys. This is a grind. Okay, but I think we're done. So let's just design logic check. This will fit in there, no problem. That is not interfering with that. I'm just looking at this gear right here. This, I'm gonna just make some spacers for it and just put them in. This is gonna spin counter to that. Let's make sure that that's the right dimension because I changed a couple of the dimensions. Maybe I will make this a little bit smaller again. 187. I started learning how to model in university and then continued learning through basically just making things. One of the best ways to learn how to model, if anyone's like really wanting to learn how to model, is to reverse model things. So like find something on your desk, like a pen, for example, and then get yourself a set of calipers, and you can find a pretty cheap pair and they're gonna be good enough. And then draw things like measure with the calipers and figure out how to draw something like a pen, and then work your way up to more and more complicated shapes. I went to the University of Guelph, which is in Ontario. It is near the University of Waterloo, which is the one that everyone knows, but I didn't know that Fusion has an AI feature. Do I know that Fusion has an AI feature? I didn't know. I know that there's an AI feature in SolidWorks as well, but it's not quite there yet. But yeah, guys, I think that we're done here. I think that we're done. In fact, one thing that actually, now that, one thing is, I changed the dimensions of this, which means I changed the dimensions of everything else, which means that the hopper that I have currently will not fit on this, and I want it to. The big central gear, how do I count to put it? Does anyone have any questions about the design? So at draft, before we call it a stream, we might as well talk about this design. Maybe we'll catch something that I missed along the way. How do I count on this not floating? So basically this is gonna be screwed around this central bearing that's on this guy. So on this guy here, there's a bearing like that. I'm gonna print it overnight tonight, and then tomorrow, maybe we'll run a stream and build this thing, which is sick. Let's go. The reason why the bottom gear is thicker is just so I have this bit of clearance, because I have this flange on the top and I just don't want this gear rubbing on this. And so I've just given myself a lot of clearance, so that's not gonna be even close to a problem. I mean, it looks like a lot, it's only 1 millimeter, which is, you know, in the grand scheme of things, that much clearance, which is not that much. There's my finger for scale. The top gear. This top gear is going to be connected through a bearing that's going to be connected on this thing. So if we look at this right here, you can see, so this is the big thing that's spinning inside. And then on top, this is going to be attached to that thing that's spinning. And then this is a bearing that's going to go in here. And this is going to be able to spin freely inside that. So that's the way I'm doing it. Is it the best way? I don't know. Is it going to work? I don't know, but we're going to find out. Okay. Does anyone else have any questions about this design, or have anything that you see that I might not have thought of or that I might have missed? One thing that I haven't done yet is I haven't put the holes into this guy. Let's just do that quickly. 1, 2, 3, 4, all equal 2.75, boom. And that's through all, perfect, save. The tooth pitch that I'm using is M1. I just use it because it just works really well and it's easy to calculate distances and stuff like that. Do I have to account for shrink rate of the material even though I'm 3D printing? Yes, you do. Generally speaking, on like big parts, the shrinkage doesn't really matter so much. But so that's actually, here's a good example. So this is going to be going into this 15 millimeter shaft. And so I made this exactly 15 millimeters, which would, if it ended up being 15 millimeters, would be like kind of like a tough press fit into this thing. But because of the shrinkage, it fits in here perfectly. And then on the same note, the outside diameter of this is 24, I believe. Let me just remember that for sure. So that's 24. And that's going to press fit into this piece right here, into this hole. And so I made this 24 because it ends up coming out at like 23.7. And so it's a perfect press fit into there. So that's how I use that. And I'm using PLA for everything here. ABS does shrink more than PLA. And, but generally speaking, I kind of just like, you know, like these parts are all going to go together, no problem. And so generally speaking, I don't worry too much about that. Thomas said, did the design that I'm referencing have the paddles? I forgot about the paddles, guys. I forgot about the paddles. Let's fix that. So we have this paddle design and the holes for the paddle design, but because of this isn't in the right spot. Let's just see where I did that. Let's move these down, boom, and boom. And then let's change this dimension to be inside a little bit. It's right on the edge, I guess. What I'm gonna do is take that off the edge, move it in a little bit, give that a dimension. For this kind of stuff, I rarely do. I find that I have a very developed intuition now, and I call it an intuition, but it's just a developed skill set I've just made so many of these parts and I've done it all with the same materials over and over and over again that often I find that I have a good sense for what I'm trying to design something here. Yeah, that's kind of the answer to that question. But like for something like, you know, for example, the golf simulator that I made, and if you don't know what I'm talking about, there's a short on my profile for that. That's like hanging, like I'm hanging like 60 or 70 pounds, and I don't have as much of a sense for like what the flex is in a 10-foot length of material, basically. So that I could probably gain something from doing some material testing, but also I could also just build it and then find out the hard way if it's not going to work. But generally speaking, like you get a 10-foot length of material and you're like, yeah, this should hold, you know, it's kind of like that. I feel like if I was doing something like really expensive, where I was like getting a part made and it was going to cost thousands of dollars, then I would probably do some FEA, which is like finite element analysis, which is structural testing in SOLIDWORKS before I actually make the thing. Okay, I don't know what I'm gonna do about these paddles right now, but I think that I'm gonna call it a stream and go get something to eat because I'm starving. And I will, I'm gonna solve the rest of the design problems before I go home for the rest of the night and get everything on the printer tonight, so tomorrow everything will be ready to be assembled. XE10 with the question, if I collaborated with Sam Altman, what would I build? I have no idea. No idea. Does anyone else have any more questions before we call it a night? Before we call it a stream, I guess? I'm not calling it a night just yet. How much food could this hopper dispense? Well, it depends on what size the food is. DM Gaming, I agree. I'm going to definitely be getting a projector for that golf sim. Who inspires me in life? You know what's interesting about that now? I'm inspired by many, many, many people who are building things and posting them on social media. My Instagram, like For You page or whatever it's called, is a lot of like cool mechanisms, art, stuff like that. So yeah, I'm inspired by a lot of people. Blue Muzzy, thank you. I am stoked that you were here. Appreciate you coming. Yeah, I'm like really excited for how this has turned out. Ivan and Miranda, 100%. Ivan is probably my favorite person on YouTube right now. If you guys have never watched an Ivan Miranda video, he's just an absolute gem. He's an absolute gem. My Insta is Engineezy _, if that's what you mean, or if you mean my For You page. And you could probably curate your own page by doing stuff like that. What do I do with all my failed prints? I'll just show you what I do with them. It's still a problem I'm figuring out. Hold on one sec. I'm showing you, go here. I put them up there and they kind of live there forever. One day I'm thinking that I'm going to like do something about that, maybe grind them up and make new filament. But for now, it's just a lot of time and energy and effort. So I don't know, it just feels like too much work. Yeah, Ivan Miranda says, go make something. How big is my workshop? You know what? You guys can get a view of it. It is this big. Here, I'll take a step back so you guys can see. Bearded printer, that actually is like it's a big reason why I only use white PLA. So I'm standing at the entrance to my workshop right now, and this is the whole thing. So we got the entrance, and then my little chill area and my desk. I think I'm gonna plan to move my desk here and like build out a little bit more of this kind of stuff on this wall. But yeah, that's my workshop. It's not crazy big, but it gets the job done. The rent of my shop. Ooh, now you're asking for some behind the scenes information that I don't know if I'm gonna tell you the rent of my shop. It's not crazy though. It's not crazy. Yeah. All right, fine. It's $3,000 Canadian a month. So it's not crazy. It's not cheap. I'm like so fortunate to be able to do it. Yeah, I'm like just outside of Toronto, so it's a little bit cheaper here than if I was like right in Toronto, I'm guessing. I actually don't know if that's true anymore. But yeah, tomorrow we're gonna do the whole assembly on stream tomorrow. We're just gonna make one single dye rotor. Yeah, $1 million exactly. Sheesh, imagine. Yeah, I mean, I was working in my basement of my house for a very long time, so my rent was free. So this is definitely more than that. But I have so much, like the space means that I can do so much more cool stuff, which is amazing. What time tomorrow? Maybe we'll do it around the same time. So like 1 p.m. Eastern Standard Time. Ooh, let me just make sure I don't have any meetings. I'm going to, oh yeah, no meetings tomorrow. Perfect. I'm going to do it around the same time. So 1 p.m. tomorrow, Eastern Standard Time. We'll put this thing together. We can probably wire the whole thing up and see if it works. Set up the YT announcement. I didn't even know that I could do that. You know what I will do though is I'll schedule the stream. Thank you so much. I appreciate it, Nakat. I love Muskoka. I was literally just there 2 weeks ago. I used to work there all summer. I love it. It's amazing. If I, as a company that I had to make something, what would it be? Oh man, just so many things. I have so many ideas for companies that I want to have that make them something. It's so chill. It's amazing. It's amazing. Yeah, it's expensive. It's very expensive in Muskoka, but it's amazing. Okay, guys, I think I'm going to call it a stream here for today. Hopefully I can see you guys tomorrow. I'll be here around the same time, around 1 p.m. And we're going to put this thing together, and it's going to be sick. All right, everyone. I hope you have a great evening or night or morning. I don't know what time zone you're in, but yeah, for sure. All right, see you guys.